at highest point only it should leave the circular path. This is a hemisphere of radius r. Okay, what is the question? Find the minimum velocity with which the block must be projected as point so that it leaves circular path. It should leave the circular path. Means what is the thing? So it should not slide on the hemisphere. It should leave there only. At highest point only it should leave that one. So let's get into the what are the forces that are acting. N and mg. So there's a point A, will take it. For it to leave at highest point A, what is the basic condition? So first we'll write here mg minus n equal to mu square r. To leave circular path, at point A, n must be less than or equal to 0. Am I right? Look at the condition here. See, it leaves circular path means it should not be in contact. If it's not in contact, because of velocity and weight, it's going to describe a parabolic path. No, n less than 0. So therefore, what is n? From here, what is n? mg minus mu square r is what n? Then this quantity mg minus mu square r should be less than or equal to 0. Or mg should be less than or equal to mu square r. Or gr root of gr less than or equal to u. Or u should be greater than or equal to root gr. What is the minimum? The minimum will become root gr. If the body is projected with a velocity equal to root gr at highest point, it is going to leave the hemisphere there only at point A only, instead of sliding. Now, if I give velocity less than root gr, it is going to slide, then leave circular path. If it is greater than root gr, definitely it will leave. This is the minimum velocity is what is telling. Sir, like if it is u is less than root gr but greater than 0, what will happen to the block? Block you are given, so somewhere when it comes here, it is going to leave the circular path. After leaving circular path, it is going to move in a parabolic path. Okay, we'll do one thing. We'll put like this. Here it will have velocity v. Now what is this phi? This phi should be less than, because if you release from rest, it will leave circular path where cos theta equal 2 by 3. When you give some velocity, definitely it's going to leave the circular path at an angle less than cos inverse of 2 by 3. If you give minimum velocity, it's going to, it need not to slide directly to leave circular path here. So where do this particular thing is used? I think if you look at the some like a bike race, it's called like a crossroad, I don't know, something like a no. So this particular thing is what the terrain will be of like this. This called like a that a hump racing, they call that one. They'll call this as like a hump racing. So here some it will be like a don't disturb class, somebody, unnecessary unmuting it. Okay, now this particular thing. So like that, what happened? This hump of different sizes will be there. And that one. So like that, what happened? It's like a closed particular in a stadiums. Like this, they'll make a humps of different sizes. A different number of humps will be there. So in a less number of in a like a 10 rounds or something, they'll put a some condition in the 10 like in less time who will complete that 10 rounds is going to the winner. Like this. Now what is the problem in winning this race means if he just slides up, anyway he has to slide up here. Now if he slides down here, it take more time for him, and there's all possibility that because the bike will have velocity when it's sliding down, when it comes here definitely it'll fall. It will not complete the path here, because by the time it arrives here, according to the concept, cos theta equal 2 by it lose contact. Though we are having zero velocity at this point, by the time when it arrives here, what will happen? It will lose contact and will fall. He is going to lose circular path. So therefore, what is the necessity for him? At highest point, he should lose circular path and he should land like this. The same bike. What is the condition? At this particular point, if he lands like this, no, then what happen? He is going to save time. Is going to save time, and also what will happen? He can save himself from falling. If he falls, what is the problem again? How he fall, we don't know, because parabolic path. Is the front wheel or the rear wheel will land on this is a very big problem. You don't have any control on this particular thing. So what is the necessity for him? At highest point only he should leave this particular track. For that he should possess velocity. For that what he should measure? He should measure what is the radius of curvature of this. That radius of curvature he should have that one, and he know value of g, and he should estimate the what is the value of the velocity, and from there what will happen? He should make his velocity greater than this. Then he will fly like this. Then he will land. So when he lands here, no problem. Otherwise, say like he will take less time in this path than this one. He has to put brakes, slowly slide down with his legs on the ground. What happens? Slowly he should make it to slide. Then again one more hump. This will take more time for him to cross. This will be much easier. No, he will land, and that too based on this speed. What happens? He can land immediately. He can cover this path in a less time. So for this, what happens? You need expertise. What is expertise? At this particular point, what velocity is needed? If the velocity is something less than root gr, what is the problem? He will not leave. He will slide. Then he'll fall. So definitely velocity should be r. What is r? R is not this one. R depends on this radius of curvature. How much radius of curvature we don't know. So therefore, the persons who are entering into that race, participating race, no, they're not allowed to see the track. So there what happened, the first round what happened, he has to estimate the track complete. There'll be like this, some 15 to 24 umps will be there, depending upon the racing, that particular thing. In the first round, he should carefully analyze what is the radius of curvature. What is the radius of curvature? I think all of you know. What is the curvature of this? And he should make a guess. Like that, he will the umps will be given numbers 1, 2, 3, and he should have a memory of that particular thing. Ump 1 need this much of velocity, ump 2 this much of velocity. Like this, what happened? He should make a memory, and at any respective ump comes, he should have the velocity greater than this. Then only what happens? He can fly. He will lose the track and he will land here. If he by chance moves here, he is going to lose the race, or he may fall down. For him that not to happen, what happen? He should slide down very slowly from rest to rest. I think definitely is going to lose race. So like that will happen. We have all this particular thing. That's why when you design road also, so the curvature here it matters. Sometimes you can see, no, when you are passing through in hilly region. So when you go straight, the car what happen will lose contact here, and it will fall. So lot of risk, The curvature of road should be made such that this u minimum Should be more or less. I think if it is more, that's better, no? So therefore a sharp curvature of like this in the road, not advisable. So it should be like a flat curvature. Road of this kind is what needed. Road of this kind, then the car what happen will fly off here. Here what happen, flying off not possible. So whatever the size of ump, you should not make it. So all these things are related to daily general life. A student must know all these things. So just be careful whenever you come across any humps like this, no, on the road. Estimate the size of hump, the height, the radius of curve. Based on that, no, the speed has to be maintained here. Okay, there's a minimum. If you project with a velocity less than root gr, what is the problem is like? It will slide, then it will lose contact. If root gr, it will live at highest point only. Okay, there's another condition is what I have brought it. Any doubt you can clarify? Just some independent topic, but it's related to our general life it is.